Okay, so welcome everybody. I just started the recording, so at this point, if you want to type your name into the chat so that we have your record for attendance, that would be great, so that we know to keep sending you data. I hope everyone has had a good 2 weeks. I'm sorry for all of the on and off weeks. At this point, there are several Fridays that I'm not available, but hopefully after we have class this week and we have class next week, then there's a break. And then we should be having class every day for a while, and I will give announcements every week, whether we're having class or whether we're not having class. Okay, so I wanted to make one more announcement before we start. So there is a textbook that I'm going to be going based on a lot. So I'm going to send the PDF of this textbook to the chat, but let me just show you the cover right now. So in order to do this, I have to share, I have to get rid of the iPad. Let me just show this. So this is the textbook that I'm kind of basing things on, at least for the statistics part of the semester. So this is a slightly old edition. So this third edition is from 2008. So some of the data sets will be a little bit outdated. There is a fifth edition, but I can't find a PDF of the fifth edition. So I don't think there's that much difference between the third edition and the fifth edition. So this is a book that I'm going to be using, and I'll send a PDF file to the chat from this book if people want to look through it. It's a big book. I mean, it's 800 pages or so, but it's very fluffy is the word. So it's not a very dense book. It goes slowly, and it has lots of examples and everything like that. So I'll send this up, and if you want to download it and look at it on your own, you are most welcome to do that. Okay, so if you want to write it down, I'll send it again, but it's called Statistics and Introduction to Statistics and Data Analysis by Roxy Peck and Chris Olson and Jay DeVore. Okay. So let me stop the share. I'll send this later. And let me now share my screen again. Give me a second. Zoom. Got it. Share content. Okay. Good. All right, great. So just one more time, just a reminder to please type your name into the chat. At some point, you only have to do it once. I have the record of the entire chat, so as long as you type it once, I'll have the record that you were here. Okay. So today, remember, we're going to be talking about statistics, which is what we're going to do for at least the first half of this semester. And we're mostly going to be focusing on descriptive statistics, which means that we have a bunch of data and we want to know how to make sense of it. How can we describe it? How can we extract, meaningful quantities, meaningful information from what might just be, some big blob of data that if you just look at all the numbers, you might not really be able to come up with any conclusions from that. Okay. Daniel Gray, do you have a question, or do you just is the hand just up? Or are you just saying hi? Okay, well, hi to everybody, and hi to Thomas Deli, and it seems like we have lots of people today, so that's great. Okay, so today what we're going to talk about is, it's pretty basic, but it's good to have this systematically done. So we're going to talk about various different ways to do graphical presentation of data. And we're not going to talk about every possible way of doing it, but we're going to talk about some of the most common ways to present data in a visual way that you can look at this visualization and things can make sense to you. Okay, so today we're going to talk about pie charts. We're going to talk about bar graphs. We're going to talk about stem and leaf plots. And we're going to talk about histograms. We're not going to do cumulative frequency curves today. This is going to be for next time. And we're not going to do box and whisker plots today. This is going to be for a while. This is going to be after discussing measures of central tendency and dispersion. Okay, so the box and whisker plots probably won't be for 3 or 4 more sessions, but we will talk about pie charts and bar graphs and stem and leaf plots and histograms today, and how to build them, and also what are some of the things that you want to be thinking about when making these visual displays. Because sometimes you have a choice of how to present your data, and one way might be better than another way, and how to think about, which is the most effective visual aid to use when you're trying to present some statistical data. Okay, but before we do any of that, I want to talk about distinctions between the types of data that we might have. So there's the first type of data that you might have is called categorical data. Categorical data, sometimes you'll also see this called qualitative data. Okay. And so what is categorical data, qualitative data? It's data that does not consist of numbers, okay? Number data is what's called quantitative data or numerical data. So a categorical data is data collected that doesn't consist of numbers. So for instance, a survey might ask a group of people whether they're smokers or non-smokers. And so the data that is going to be collected is each person is going to say smoker or non-smoker, so that those are not numbers, or what political party they belong to. And the political parties, they don't have numbers, they have names. So all of the data that you collect from this is not necessarily going to be a bunch of numbers. It's going to be a bunch of other types of responses, but it's still data. I mean, data doesn't have to be a number. So for instance, if you're asking a political party question in the United States, so each possible response is called a category. So in the United States, the categories might be Democratic, Republican, which you have your 2 major political parties, and then other or independent. And, we do have lots of small political parties, but often maybe for the purposes of whatever survey you're doing, the other parties are so small that it's not so important to know exactly how many people belong to each individual one of those parties. It is more important to just know, well, are you in one of these small parties, and have that as one category. So like when designing a survey, you have an option of, what categories you want to allow for possible responses. So you could just allow people to write whatever they want, and that's okay. But sometimes when you allow people to write whatever they want, the data is not so easy to present. So at least in the United States, usually the political party question, the choices would be Democrat, Republican, other, or independent. And sometimes maybe independent and other might even be lumped into one category that you would just call other. In Liberia, of course, there's many more political parties and many more political parties that have real followings and that matter. So you would have a lot more categories. It probably wouldn't make sense to have only 4 categories in a Liberian survey for this. You'd probably have 10 categories or 20 categories. And so how do we present categorical data? Categorical data. Generally, especially when the number of categories is relatively small, so you're talking 4 categories or 5 categories or even 10 categories, is often effectively presented as a bar graph or a pie chart. If you really have lots and lots of different categories, you have 100 different responses that people are doing, then things like pie charts and bar graphs become a little bit less useful, less good to get information from. And you might instead want to see if you can collapse the categories somehow, group them together so that you have fewer categories and you have something reasonable to present. Okay. Yes, question, Ed.
Yes, no, it's not a question, but can I also say that this category data can I also refer to it as group frequency distribution?
Yeah, you can talk about it like that. Yes, this is going to be related to, you can collect everything. You can collect this data as a frequency distribution. Yeah.
No, we have 2. We have on group and group. So this category data, we want to be placing group frequency data.
Mm-hmm.
Group frequency distribution.
Right. I mean, so you can all that you can say is that you can make a frequency table of categorical data. It's just that the entries in your table, the categories will not be numbers; they'll just be categories. But you can make a frequency table.
Yes, in a group form.
In a group form. Yes. Yes, you can do that.
Okay.
Yeah. Yes, you can do that. Okay. Other comments? Okay. So let's take something that I pulled from the internet. So this is a population survey for Liberian ethnic group data from 2008. So at that point, from the census, at least as percentages, I don't know how many people were actually surveyed, but for percentages, we have that Pele is 20.3%, Bassa is 13.4%, Grebo is 10%, Gio is 8%, Mono is 7.9%, Crew is 6%, Loma is 5.1%, Kissy is 4.8%, and then other, which I didn't actually write down, but we can figure this out, right? So I forgot to write down the percentages for other. So let's just do a quick calculation. So 20.3 plus 13.4, that's 33.7. This is 43.7, 51.7, 59.6, 65.6, 70.7, and then 75.5. So that means other in this case is going to be 24.5%. That's what's left over. So I just need to add up to everything to get 100%. And so when you have data that really you want to be viewing as percentages of the whole, you want to know how much of the whole each category makes up, then usually it's very good to use a pie chart. Now, the problem is constructing pie charts by hand is usually very, very difficult. You have to draw a circle, you have to convert everything using a protractor to exactly the right shares of a circle. And I mean, unless you have a very simple amount of data or, really a lot of space, then constructing pie charts by hand is usually not as useful as constructing it using some sort of software. So there's lots of computer programs that will let you construct pie charts. So if you have access, to a laptop or on your phone to something like Microsoft Excel or Google Sheets or OpenOffice Calc, you can use all of these things to construct pie charts. But let's just say you don't have any of that stuff. Okay, if you don't have anything, there are now lots and lots of websites that you can just go to and use them to construct a pie chart. Okay, so one of these websites is this. This is from the U.S. government. They just have a way that you can input your data, and it will make a pie chart for you. So let's actually do this. Just so that we can see. So let me copy that website in, and I'll show you how it works. What do I want to do? So let me do this. Okay, so if you go to the website, let me share my screen. Where are we? Here. Okay, so if you type in that website, all I did was I copied and pasted the website address. So we can have so what it does is just lets you put everything in. So the number of slices we'd like to display. In this case, it's 1 to 15. We had, I think, 9 different groups that we were going to write. So in this case, the title of the graph would be Liberian population by ethnicity 2008. Okay. And so slice 1, I'm just going to write these in the order that I had. So this is kind of in descending order. So Pele, you'd write 20.3. You can do it. You don't need to write the percentages. It'll make the correct pie chart anyway. So Bassa in this case is 13.4. Grebo is 10.0. Gio is 8.0. Mono is 7.9. Crew is 6.0. Loma is 5.1. Kisi is 4.8. And then other is 24.5. So I took this from the internet. And so now what we can do is if we want to just create a graph, it'll say which of 2 different file types you want. It doesn't really matter, but we can create a printable graph here. And then, here it is. So this will give us, all of the different slices, and then it'll give us, and here's the key. In this case, it distinguishes each wedge by a color. And what's nice with the pie charts is it's good for comparing, how large one quantity is compared to another quantity. Now this one is, there's a couple of things that are a little bit annoying because it uses the, oh, oops, that's not what I wanted to do. That's not what I wanted to do. Okay. Couple of things are a little bit annoying here because it uses the same color for more than one wedge. So that's not great. So for this application, you might want to only use it when you have fewer categories. But there are other applications that will also make pie charts for you, and some of which have more colors. And if you just Google like make a pie chart online, there are lots of places that will just do it for you. So you can do that right on your phone if you need. Okay, so and again, doing this by hand would really take a lot of work. And so now the software is free and it's easily accessible. So that's usually the best way to make pie charts. Okay, any questions on this?
Oh,
Yeah,
really?
Yeah, Linford?
Yeah, is it possible that we can use the percent sign there?
Yeah, sure. If we wanted to do that all, I think if we use the percent sign, it will still give you the correct sizes. So let's see if I do percentages everywhere. Do the percentages everywhere and let's see what happens. Oh no. So in this case, it doesn't. So this application doesn't let you use the percent sign. So it's just for this application, it needs to know that it's all the percent. What you could do is if you wanted everything to be a proportion of the whole, instead of using the percent sign, you could put everything in as a decimal if you wanted everything to add up to 1. So you could move the decimal point 2 spaces over for all of these. So here you could have 0.08 instead of 8%. This would be, 0.079. Here would be 0.06. This would be 0.051. Here would be 0.048. And here would be 0.245. And then if you did the graph over here, you'll get the same thing, but with proportions instead of with numbers. So here, everything's just been divided by 100 so that you can get the percents.
Thank you.
You're welcome. So
Okay,
this is probably,
yeah,
this is, by the way, not the most powerful pie chart maker. Hello, yes,
Hello?
sorry. Yes.
Hello?
Yeah.
Ed.
This is the part that I want to ask a question quickly
Mhm.
because we have many ways to interpret the data. We have the bar chart and we have the bar chart.
Yeah.
Okay, for someone who actually does not know nothing but statistics, because for the bar chart, it will give you the direct representation frequency distribution where you have all the bars going upward, you know which one is shorter and which one is longer. And for the bar chart, it'll give you the pictorial circular data where you see the percentage. Like for this one we have now, the percentage of people in Grand Basel and things they did. So which one is preferable for people who don't know statistics? If you are presenting data to them with the bar chart or the pie chart, which one is preferable?
I mean, so it depends. So there are we'll talk about this a little bit. So there are certainly cases where the bar chart is preferable to the pie chart. There are cases where it does not make sense to do a pie chart. And we'll see, we're going to do bar charts next. And there are cases when there's bar charts there where it really is preferable to use a bar chart instead of a pie chart. So usually if you can do a pie chart, you usually can also do a bar chart. But often the pie chart is a nice illustration when you're really looking at one big set and you want to know how many people in that set or how many things in that set fall into different categories. Sometimes the pie chart is like it's a nice visualization of how to do that. And by the way, let me just say there's a better, what was the other, if you do like make pie chart online, what was the other one so this piechartmaker.co is also good, and it's a little bit more sophisticated than the other one. So in this case, let's just do it again. So here, what you do is you enter the labels. So if you wanted Pele, Basa, Grabo, Gio, Mono, Crew, Loma, Kisi, other. And then here we have the values. So here, I think you can use percentages. Let's see. Or actually, let me just see. Blah, 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 blah. Yeah, so 20.3%, 13.4%, 10.0%. So the important thing here is you have to enter the data, the percentages in the same order that you enter the categories, right? So you have to make sure that you put them in the same order. So 7.9%, 6.0%, 5.1%, 4.8%. And then this is just a thing that lets you put a hole in the middle of the pie chart. So with a 0 hole, you get a full chart like this. But if you put in a percentage, it's basically like a proportion of the radius that's taken up by the hole. So if you want a little hole like 0.5, we'll see that that's going to make this. So here it actually lets you do. It lets you actually. So you probably do not want to do percents here. Get rid of the percents, and instead, what you can do is, as the text, you can put percentage, and it will calculate the percents for you automatically. And now, let's have a title. Liberian population by ethnicity in 2008. And if we generate the graph, you click on that, and there we are. And so this one, I think, is maybe a little bit nicer. Here you have a little hole in the middle. If you don't like the hole, you can set the pi hole to 0 instead of to 0.5. And now you have the same graph, just without the hole. And this is a little bit better. So you can either have, here they have the labels just with lines to each section of the pie chart. And if you don't like that, then you can also just put the legend on the left or on the right. So here, if I put it on the left instead, now you just have the color coding. And also when you hover over one of these, then it tells you which wedge of the pie chart you're looking at. So yeah, so this one is I'd say this one is probably a little bit better than the other website, but you can use either of them. And if you just put it into Google, make a pie chart, and you'll get a bunch of matches. And this one I think is pretty intuitive. I'm not going to go over how to do it in Excel or Google Sheets right now because different people might have different programs. So I don't want to do one that some people will have and other people won't have. But this is, you can just type it in on the web, and you'll get a pie chart maker like this. Okay. All right. So should I move on to bar charts, or does anybody want to say anything more about pie charts?
Yes. Can I just come in? Maybe probably for those who have the computer, though, maybe they might not have internet access. You can use the Excel to create pie chart.
Yes, so you can use Excel to do pie chart.
Because if you look at the first column A, you put all your number that you highlighted, you go to insert, you see a different graph. You see pie chart, you see line graph, and so forth. So you can click on the one you desire, and you have a pie chart.
And so question, so is Excel on most computers?
Yes, Excel. In as much you have Microsoft or package, you have Excel.
Okay, great. So I didn't know how common it is to have Microsoft products. So if people have Excel, then maybe next week I'll go over how to do some of this in Excel.
Okay, thank you.
Okay, great. For now, I'm just going to use web stuff that you can get to. But yeah, so if Excel off the web is easier, then maybe next week I'll go over how to do some of this in Excel. Okay, great. Okay, so let me stop the share now and go back and share my screen here. So let's share content. Screen, broadcast. Okay. So here is what we have here. So now let's look at other categorical data. So what do we want with bar graphs? And sometimes you'll see these called bar graphs, or sometimes you'll see them called bar charts. They're the same thing. So bar charts are a little bit easier to construct by hand some of the time. So the way that we write a bar chart is, again, for categorical data. Then on the horizontal axis, we list the categories, and we tend to do them evenly spaced. And the vertical axis is going to represent frequencies. And for a bar graph, you have two options depending on what you want to do. You can write the absolute frequency, how often a particular category occurs in the data, or you can do the relative frequency, where you write how often it occurs as a percentage of the responses. And of course, all of the software packages, Excel, Google Sheets, all of these things will do bar graphs also. And that same website you can also use to do a bar graph. So for instance, this is something that we could do by hand. I mean, kind of basically, so there was a survey in 2005 on motorcycle helmet use in the United States. Okay, so what they did was they didn't ask the motorcyclists, because sometimes when you ask people things, they're not necessarily going to tell you the truth. So what they did was they sat on a road where there were lots of motorcyclists going by, and they just looked at all of the motorcyclists that went by, and they counted 1,700 cyclists. And this was to see how many were wearing helmets and how many were not wearing helmets. Okay, so it turned out that 731 of them were not wearing helmets. 153 of them were wearing, it's called a non-compliant helmet, which means it's a helmet, but it's not really, it doesn't fit the regulations, right? So a helmet's supposed to cover to the bottom of your ears, and these helmets were too small. They didn't cover the bottom of the ears. And then 816 were wearing a compliant helmet. Okay, so if we wanted to do a bar graph for this, this is, as long as we don't care about getting it exactly precise, this is not so hard to do by hand, right? So I have three categories right here. No helmet, which maybe I'll abbreviate it because we don't want to write it. I'll call this no H. I'll call this over here a non-compliant helmet. Why is this not writing? Yeah. I'll call a non-compliant helmet here NCH, and then a compliant helmet I'll call CH. Okay, so this way we're able to write the categories a little bit more easily. So let me put these over here. So we're going to have, I guess, no helmet. And then here we're going to have non-compliant helmet. And then over here, we're going to have compliant helmet. And now for categorical data, we're going to build bars. So this side is going to be the frequency. So let's do this with an absolute frequency, right? So one important thing is to get the scale correct over here. So we see these numbers are in the hundreds. We're measuring like 100, 200, 300, up through 800. So probably for the scale over here, it makes sense to mark it by 100s. And so this is a matter of taste, but usually depending on your data, certain scales are going to be more useful. So if I mark my vertical axis by 100, 200, 300, 400, 500, 600, 700, 800, 900. And so this is going to be, sorry, yeah? Sorry. Yes, sorry, who has a comment? Prince, yes, Prince, what's going on? Sorry, only unmute if you're asking a question. So sorry, Prince, can you unmute yourself and your comment? Yeah.
So what would be the interval between this, or you just decided to get, from one, or to start from 100 and then to continue to 900? Do we have any interval that maybe you can follow?
Right. So there's no real rule. Okay. You have to just, there's not like a formula that's going to tell you what intervals to do. What you want to do is choose a scale that's going to illustrate the differences in your data. So for instance, a bad scale would be, well, doing this by ones would be a bad scale because I don't have enough space for the bars if I do them by ones. Doing it by 10,000s is also a bad scale because if I did it by 10,000s, then all of these bars would be much less than 10,000 and it would be difficult to distinguish them. So probably what you want a scale where the maximum measurement you have is going to be near the top of the scale. And the minimum measurement that you have is going to be near the bottom of the scale, and where the intervals are spaced out enough so that the bars really will have differing heights so that people can see them, right? The only point of a bar graph is to make it easy for people to look at something and get information from it. So you choose whatever frequency is going to make that information clear. And there may be certain, rules of thumb that people use, but there's not one rule that says this is what you have to make your frequency intervals. You just want to make them something that's going to make the information clear. Okay?
Okay.
So, you're welcome. Sorry. So in this case, so now what we do is we're going to draw an equal width bar. And sometimes it's nice to make all the bars different colors, just for visual. So maybe I'll make this first bar green. So no helmet was 731. So I'm going to make a bar with a given width. I'm going to go up to 731. That's about here. And I'll just draw this bar. And if you're drawing this on a big piece of paper, then you might want to have a ruler or something. And you can fill it in however you want. Okay, so this is my bar. Okay, so this is my green bar. It's good enough for now. So that's going to represent no helmet. And non-compliant helmet, that's only 153. So that should be about halfway between 100 and 200, maybe a little bit more than halfway. Let me use a different color for that bar. Maybe I'll use purple. And so I want to make it the same width. You want all the bars to be the same width. And so you go up like this and over like this, like that. And we'll fill this in. Maybe that's not actually the same width. Let me erase some of it. Okay, so again, on a big piece of paper, you could measure this out. But for now, I'm just kind of drawing this loosely by hand. Okay, and then a compliant helmet was 816. Let's use maybe orange for that. So 816 is going to be over here, a little bit above the 800. So I'll make my bar width orange, try to make it about the same size. I'm going to go up, try to do it straight to about here. That's about 800. Over here and down. Okay. And go fill this in. And again, if you want to do this on paper and you want to be careful, then you can try to measure everything, or you can do what most people are going to be doing, which is to use Excel or use a bar chart maker from the internet. Okay. So, but in this case, this is a pretty easy bar chart, and it shows us clearly that most people are either wearing a compliant helmet or not wearing any helmet at all. And it's roughly about half and half, with some small number of people wearing a non-compliant helmet. Okay. So this is one way of doing it by hand, and this is what we call. By the way, I'll take the question in a second, but I should write this. This is absolute frequency. And if we wanted to do the corresponding frequency table, we would have just a little table with a category and the frequency. And the categories would be, no helmet, non-compliant helmet, and compliant helmet. And our frequencies, we would just write down here, 731, 153, and 816. Okay. All right. So yes, a question. Yes, Marcus.
Yes. Why the absolute frequency is 900? Why it is 6 to 900 instead of 816?
Oh, well, because remember, the absolute frequency is just how many measurements you have. Or so how many times did you see somebody wearing no helmet? So the absolute number of that is 731. They saw 731 motorcyclists with no helmet. So we're doing it in intervals of 100 just because that's an easy way to make the graph so that we can see it and it'll look nice. If it was a relative frequency, then everything would be a percentage. Right. So for a relative frequency, everything would be a percentage. And so we can do a graph with relative frequency if we want to. But before we do that, any other questions?
No question.
Okay. So let me, sorry. Okay, sorry, I need to mute. Okay, let me just say, how would we do relative frequency? Maybe I'll add it here. So relative frequency, let me do another page for relative frequency. Okay, so let me add, okay, so how to do relative frequency. Maybe I'm only going to do the table. I won't do the chart separately for it. Sorry, question?
Yeah, you just
Yes, Gabriel?
no the relative frequency. From the relative frequency, all you need to do is just deliver the value for no helmet, all of that, you just divide by one. That is something like that. So
Right. Exactly. So let's just do it. Yeah. So let's just do it quickly. So by the way, over here, the total number of measurements, the total in this case is 1,700. Over here, that's how many were observed. If you add up all these numbers here, you get 1,700. So what do we have to do? So for relative frequency table, if we just have, so category and relative frequency, okay, so here we have no helmet, non-compliant helmet, and compliant helmet. And so for the relative frequencies, here we had 731, 153, and 816. So for the relative frequency, we just take 731 divided by 1,700 and write this as a percent or as a decimal, 153 divided by 1,700, and 816 divided by 1,700. And so let me just do that. So 731 divided by 1,700. So this is so this here is 0.43. We could do it as decimals or we could do it as percents. So 153 divided by 1,700 is 0.09, and 816 divided by 1,700 is going to be 0.48. So if we wanted to do relative frequencies, we can put them in a table like that. Here we have the formula: relative frequency equals the absolute frequency divided by total number of responses. Okay, or to total number of data size. Okay, so we can do the table, and if we wanted to do a bar chart with the relative frequencies, it would be the same as our old one, and in fact, it would look exactly the same. The only difference is that our axis would be labeled differently. So yeah, Thomas?
My question is, will it be possible to change the position of the category to the vertical side?
Yeah, so if you wanted to, you could arrange the categories in descending order. And that's sometimes a useful thing to do. So you could write the category where maybe the category with the largest bar, with the largest frequency comes first, and then the category with the next frequency, and then the category with the next one after that. So that's sometimes a useful way to organize data. When you really only have 3 categories, it doesn't matter that much. Sometimes that can be useful when you want to get some data that's a little more similar to a pie chart. You want to see kind of how much of the whole is everything. You could have also used, sorry, I'm getting a lot of feedback. Sorry, I was getting a lot of feedback. You could also use a pie chart for this data. This is data that's completely reasonable to use a pie chart for. You're looking at a total population and you want to see which percentage of the population does something, engages in a certain practice. So you can totally use a pie chart for this, and that would also be a reasonable thing to do. But if you were going to use relative frequency, then you would not label 100, 200, 300, 400, but you might label 10%, 20%, 30%, 40%, 50%, and so on, or maybe even by 5%. Because if your highest measurements are 43% and 48%, then maybe you would make your scale here 5%, 10%, 15%, 20%, and so on. Okay. So, but in the end, the bar charts, the chart itself is going to look the same. It's just that the axis will be labeled differently. Okay. Right. Other questions or comments on this?
Thank you.
Okay, you're welcome.
Hello.
Yes, hello, Ed.
Yeah, let's go back to the relative frequency.
Yep.
Okay, I see that we have 731 divided by 1,700. And you're saying that it's 0.43?
Yeah, sorry, let me write that down specifically. This is 0.43, this is 0.09, and this is 0.48.
731 divided by 1,700, is that 0.43?
Yes.
Okay.
Yeah. Okay. Good. Okay, so let me go back a little bit to the question that was asked. So bar graphs versus pie charts, right? Which is a better thing to use depending on your data? Well, it's not always clear which is better to use. So, but there are a few principles that are worth looking at, right? So, for instance, if there's lots of categories, a pie chart is often very difficult to read. It's hard to read a pie chart that has 20 categories, for instance, right? The wedges just get too small and it's not going to be very effective.
Yeah, baby, I was going to call you.
Presenting the data.
Hello?
Okay. Whereas a bar graph, even for something like 20 categories, can probably be better. If the important concept is what proportion of the whole each category takes up, then a pie chart can be a nice way to present that. It can be a useful thing for people to see. But the one kind of serious principle is that if there is no real concept of the whole, then a bar graph is definitely a better thing to use than a pie chart. So for instance, so here's two questions. So if we wanted to present the data, so if you divide Liberia's land into agricultural land, settlement land, and forest land, and you wanted to write the percentages of that, what would be probably a good method to use to present that?
Hello.
Hello, yes, Tomas?
Yeah, I prefer you.
Sorry, sorry, I was not getting you, Tomas.
Yeah,
Hello?
Frederick.
Oh, Frederick, yes,
Hello?
sorry.
Yes, I would prefer using the bar graph.
The bar graph or the bar graph? Okay. And Tomas,
Hello?
what do you prefer?
I prefer use pie
Yes.
chart.
Pie chart. Okay. So the point is you really could use either one in this case. So I would probably prefer a pie chart, but in this case, a bar graph would also be okay. Okay. But for instance, let's say instead that you're looking at, this is actually a bad example. This is a bad example. Let me actually try to come up with a better example on the fly. This example is not good over here. So let's say that you wanted, let me say, okay, let me, I don't want to do this on the fly because we only have so much time, but what I want to do, okay, so this is a challenge, right? So come up with, and this is not good because this is actually not categorical data. This is numerical data. So I don't want to use this as an example. So come up with an example where a bar graph makes more sense than a pie chart. Okay. And I will send to the group something. I will send to the group something, but I just don't want to come up with it in 1 minute right now because I want to move on to some other things. Okay. So I'll come up with something and we'll talk about it next week. Okay. We've already seen one reason. If there's really lots of categories, a bar graph is better, but there's other reasons why like a pie chart is maybe just kind of not showing you exactly what you want. In particular, if you're ever going to be doing comparisons, like you have something, if you have something where you're doing some data at one time, and then you do the same survey, but a year later, and you want to compare the two, it's often much easier to compare two bar graphs than to compare two pie charts. Okay, so bar graphs are often better for comparative data, but we'll talk more about comparative data next week. Okay, so for the rest of the today, I want to talk about numerical data. So numerical data, this is also sometimes called quantitative data. What am I? No. So quantitative data. Okay, so we have various ways of presenting quantitative data where the data themselves are actually numbers instead of, are you wearing a helmet or are you not wearing a helmet? So today we're going to talk about stem and leaf plots, and we're going to talk about also doing histograms from frequency tables. Okay, and later we'll do cumulative frequency curves and box and whisker plots. Okay, so stem and leaf plots are useful when you have numerical data where there are not too many observations. So a stem and leaf plot is not going to be good if you have 1,000 data points. It's just going to be too much to have a useful stem and leaf plot. What it does is it gives you a direct way of turning numerical data into a suggestive picture. And the idea is we take some number of leading digits in the data, and these are going to be what are called the stem values. And then we take some number of trailing digits to be what are called the leaves. And the most important thing when you're doing a stem and leaf plot is you have to be consistent within your data set about where you split the stem from the leaf. You always have to do that at the same place value for every entry in your data set. And sometimes this will result in some weird things, like the stems for certain entries will have different numbers of digits, or sometimes the stem will be 0, and that's fine. So all of this is maybe a little bit difficult to understand until you see what's actually going on with a stem and leaf plot. So let's do this with an example. So this example is, so the median ages in 50 US states projected in 2030. So I don't even write the names of the states here, because when we do the stem and leaf plot, the names of the states are not going to matter. Okay, all that matters are these 50 numbers that we have here: 41, 33, 39, 29, 37. So in this case, what do? We make the first digit, everything here is just a 2-digit number. So it's pretty simple, right? So we always just make the first digit the stem and the second digit is the leaf. Okay, so we imagine kind of dividing each number in between its first and second digits. I'm not going to draw these lines for all of them, but this is the idea. And so when you have a reasonable amount of data, it's usually easy enough to write a stem and leaf plot by hand. Okay, so in this case, what would be our stem and leaf plot for the data? What we do is I draw a line and I look at all of the stems. Remember, the stem is the first number. So in this case, if you look at all the data, it turns out that the stem is always either 2 or 3 or 4, right? So in this case, for my stems, I'm going to write 2, 3, and 4. And then what you do for the leaves is you look, so for every single thing that starts with a 2, there's not very many of them. It looks like we have only one state that starts with a 2 for its median age projected in 2030. So we write all of the ones digits that you have after that. So in this case, for the 2, we would have a 9. And that's it, right? There's nothing else, because that's the only point in our data that starts with a 2. Now for the 3s, you're going to have a lot of data points that start with a 3. And so when it's a single digit, we just write all of them. Okay, so I'm just going to go through my list. So we have 33. So it's a 3, a 9, a 7, a 6, a 4, a 6, a 9, an 8, an 8, a 9, a 9, an 8, a 9, an 8, a 9, a 7, an 8, a 9, and an 8, and a 5, and a 0, and an 8, and a 9. So that's my 3s, and then I can do the same things for 4s. I'm just going to take all the data measurements that have a 4 on them, and so I'm going to do 1, 1, 4, 5, 2, 0, 7, 0, 0, 1, 0, 6, 2 1 5 0 3 0 2 1 1 2 4 7 2 6. Okay. So this is kind of a compact way of writing all of the data. And from looking at this, you can tell that, well, the median age is usually not in the 20s, and about as often as not, it's just as likely to be in the 30s as to be in the 40s. Okay. So you can do this by hand. You can use another website here, and you can do these on Excel as well. One of the nice things about doing it on the website is that it'll automatically sort the leaves by order. So instead of just having this random numbers, it'll start with the 0 and go up to the 9, and it'll just repeat numbers when they need to be. By the way, Francis, do you have a question?
Yeah.
Yeah, so if I see Francis you have your hand raised. Do you have a question?
Yeah, I have a question here.
Okay, Prince.
And when you get a 2, I don't know if you can start with 1, and then that is my first question. So whether you can start with 1. And the second question is, within all those data that have been given here, we have a lot of numbers that are given, but just within the data, you just choose 9 to be at the place of 2. Yeah, to be at the place of 2. So where they came from?
Okay, so we don't choose a 1 because we don't have anything in our data that starts with a 1. Right?
Okay.
We don't have anything in our data that starts with a 1. So there's no reason to put a 1. I mean, you could put a 1 here. It would just be blank on the other side. You could do it, but there's not really any reason to do it. The 2 with only the 9 is because the only data point we have that starts with a 2 is this one point here, 29. So for the 2, all that we have is a 9. For the 3, we have lots of data points that start with a 3. So I'm writing the last digit for every single one of those. And same thing with the 4. Writing the last digit for every one of those.
Yes, question.
Yeah.
Frederick, question.
Sorry, question. Yeah, Frederick. Yep.
Yes, I want to know if the arrangement of the numbers in the leaf matters. If arranging in ascending and descending order matters.
I think often it does. So I would say this stem and leaf plot that we just did is okay, but it could be better, right? So I think arranging them in the order does matter because it makes it a little easier to see if you have a lot of measurements at the top of each class, or if it's more at the bottom of each class. And what you can do, which I won't do by hand, but I'll show you on the website, is that you can even do what are called split stems, where you list each stem twice and you break up the leaves into the high part and the low part. So for instance, I could split this 3 up and make 2 different rows, where the first row has only the low values, meaning the second digit is 0, 1, 2, 3, or 4, and the second row has only the high values. That's 5, 6, 7, 8, and 9. Sometimes that can give you a more useful plot. And I could do the same thing for the 4. I could have the low 4s, which is like 40 through 44, and I could have the high 4s, which is 45 through 49. Okay? So let me actually show you what that looks like. You're welcome. Let me show you what that looks like on this website here, this calculatorsoup.com. So let me just bring this up. So I'm gonna share screen. Okay. Let me go here. Okay, so I'm gonna go do this calculatorsoup.com. So we have our stem and leaf plots. Okay, so let me enter some data. Let me just enter this same data set. So here we can do, I'm just going to enter the data set. So 41, 33, 39, 29, 37, 36, 36, what did I do? 36, 41, 44, 34, 45, 36, 39, 39, 38, 38, 42, 39, 40, 39, 47, 38, 40, 40, 39, 41, 40, 46, 38, 39, 42, 41, 45, 40, 37, 43, 40, 38, 39, 42, 41, 41, 42, 38, 35, 30, 44, 38, 39, 47, 42, and 46. Okay, so here's the data. And so you notice you can pick the leaves. In this case, our leaves were 1 digit. With these 2-digit numbers, you're always going to have the leaves be 1 digit, but you can have it list more digits if you want. And so I can calculate it, and it's going to give me the same plot that we have before. I click on calculate, and it's going to give me the 2 with the 9 and a 3 with a whole bunch of stuff and the 4 with a whole bunch of stuff. But I can do what's called split stems, which is exactly what I was talking about before, where each stem is going to get 2 rows related to it. And so if I click on split stems and now I calculate, now we have something that's maybe a little bit more visually useful, right? We have kind of, there's nothing for the low 2s, only 29 for the high 2s, only a little bit for the low 3s, just 3 measurements, a lot more for the high 3s, a lot for the low 4s, and then not as much for the high 4s. And you also see that these are automatically put in the correct order here. And so what this tells us, if you imagine kind of drawing a curve that has the sizes of the numbers like this, then what this is telling you is that the median age for most states, it's probably clustering around the high 30s and the low 40s. That's what you're usually going to have in the United States in 2030. And as you get younger than 35 and older than 45, that the number drops off rapidly. You don't really expect that to be the median. Now, if you did this for Liberia and its counties, you would get a different distribution. You would have a much younger median age. Yes, question?
Hello?
Yes, Tomas?
Yes, Tomas. Okay, my question is, what will happen if we have 3-digit, if we are dealing with 3-digit number?
Okay, so that's a great question. That's a great question. So let's do a second example. Okay, and we're going to do this one in the, let me do this one on the website, but let me just first show you the data. So okay, let me zoom here. So show content, screen. Okay, so by the way, we'll probably just do stem and leaf plots today. We'll get to histograms next time. So here is a survey where they surveyed all the countries in Northern Africa. Unfortunately, I couldn't find the survey for Western Africa, but for Northern Africa, I found this. And this was the percentage of primary school age children enrolled in school for each country. So they did every country in Northern Africa, and in each country, the number represents the percentage of primary school age children who are actually in school. And again, this is from, I think, 2000. This is from 2008, I think. So here we have entries with 3 digits, right? So in this case, if you're going to pick the stem to be the first digit, then over here we have, okay, they're not 3-digit numbers, but they're a number with a decimal place. So it's a very similar type of thing. You still have 3, you have a total of 3 numbers. So what you can do is you have 2 choices when you're doing your stem and leaf plot here. So it's the only reasonable choice is to take the stem to be the first digit. Because if you take the stem to be the first 2 digits, then everything's just going to be in its own row, and the chart's not going to tell you anything. But if you take the stem to be the first digit, you have a choice. You could choose the leaf to be just the second digit, or you could choose it to be the second digit and the decimals place, right? So what I'm going to do is I'm going to put this data in back into the website, and we'll see what the plot looks like when we use only the 1s digit, and then when we use the 1s digit and the decimal place digit, the 10th digit. So the good thing is that I don't have to type it in because I have this written down and I can copy and paste it. So let me continue. I'm going to go here. So I'm going to have new data that I'm going to take from here. Where am I here? Okay. So this is my new data, which I'm going to just paste in right here. Let me make sure my spacing is okay. Sometimes these websites are very sensitive to spacing. So you need to make sure there's exactly one space between each of your data entries. So the first thing I'm going to do here is I'm going to select the leaves to be 1 digit. So when the leaves are 1 digit, that's going to ignore the decimal points. Okay, it's only going to take 1 digit of the leaves. And it's going to, by default, it's going to use the stem as the first digit. So if I calculate this here, oh, do not use decimal numbers. Oh, does not handle decimals. Oh, okay. All right. Well, okay. So let's just get rid of the decimal points and imagine that we had 3-digit numbers for the stem and leaf plot. Okay, I'm just going to get rid of the decimal points. Okay, so if we use that the leaves are 1 digit, we calculate, and oh, there's a decimal still there. Okay, we calculate. Okay, so this is kind of like a bad plot, right? Because this is just using, oh, and I don't want to split the stems. Right, so this is one of the things. So if we do this, if I say the leaves are 1 digit, then it's taking the stem to be the first 2 digits, which is kind of silly. This stem and leaf plot tells us very little. So that's probably not what we want to do. If the leaves are 2 digits, then that makes a little bit more sense. It's taking the stem to be 3, and then here are the leaves. So what it's doing is it's just giving each of the measurements in terms of 2 digits, and it's leaving a space between them. If you want to, you could put a comma between them, or you can put spaces between them. I think when you're writing, it's probably easier to use a comma. And what we see from this stem and leaf plot is that most of the countries that are surveyed, if we remember what this data originally was, most of them have in the 80s or 90s% of primary school children actually enrolled in school. There's only a few countries where the numbers are much lower than that. If you're making this plot by hand, so I guess this website doesn't do this, but you could also decide that you don't care about the last digit at all. Okay, in order to get the visualization of the plots, you don't really care about the tenths of the percents. So you could just do the same thing up here, but just change your data so that the last digit doesn't exist at all, because you're saying you don't really care about tenths of a percent. What you want to learn from this data is not going to be so sensitive. So if I just get rid of the last digit of everything here, and now if I do a stem and leaf plot where the leaves are only 1 digit, then I can calculate it. And now I have a standard stem and leaf plot for 2-digit numbers. And you see that I have a lot of stuff in the 80s and a lot of stuff in the 90s. And by the way, let's imagine there was some country that had 100% of primary school students enrolled. Then what would happen is that one of the stems will just be 2 digits long, right? So if I calculate it this time, if one of the countries has 100, then the stem is going to be 10. And this is because of what I said earlier, where I said it's very important that the split between the stem and the leaf is at the same place value for every entry in your data set, right? So here, the split between the stem and the leaf is between the tens place and the ones place. And that's going to be the same even here. Even if you have 100 as one of your measurements, the split here is not that you take the 1 and you put a 0, 0 here. The split is that you have your split between the ones place and the tens place, just like you do everywhere else. And if that means that your stem will have more digits for some of your entries, then so be it, right? So imagine there were another country where only 7% of the primary school students, primary school age children, were actually in school. So with that 7, what's going to happen? Well, again, I need to always have my split between the ones place and the tens place. And so that means for that measurement, the stem is going to be 0, right? Because I need to put a 0 there in order to have something in the tens place. And that's okay. So stems don't always have to have the exact same number of digits. If your data are very wide-ranging, You might have a stem with a 0, and you might have stems with more than 1 digit. What is very important is that the stem and the leaf always have to be separated at the same place value, no matter which data entry you're looking at. So in this case, we've chosen that the stems and the leaves will always be separated between the ones place and the tens place. That's why these leaves are 1 digit. It means that it's only the ones place that's going to be on the leaf side, and everything else is going to be on the stem side. Okay. So, yes.
Hello?
Hello, Tomas.
Yes, that.
Hello?
Ed.
Yes,
Hello?
yes. Oh,
Sorry,
hello, Dan.
Ed and then Tomas.
Okay,
Okay.
Thomas, go ahead.
Okay. The I'm seeing 0, 1, 2. Okay, the
Right.
first. Okay, so when we have stem as 0, that is mean that particular data is just 7.
Mm-hmm.
When we have 1, that is mean that data is what is 10.
Well, the one it's 10, but since we have no data measurements, you see there's no leaves because there's not any actual data that starts with 1. The reason the 1 and the 2 are here is that if you start with your stem at the bottom, then what it's doing is it's filling in the spaces from your lowest data point to your next one. You don't have to do this. If you wanted to just skip the 1 and the 2 rows in your stem and leaf plot, that's okay. It's just that this software puts the rows in, but you don't have to. You don't have to put in the empty rows.
Okay.
Okay.
Yes, Dan.
Thank you.
Yeah.
Yeah, I have
Okay.
an observation. Okay, with this stem, with this stem and leaf method that you just applied.
Yep.
Anyway, it's my first time seeing it. But okay, after the stem and leaf method, can I go with probably my class interval from the stem and leaf method?
Mm-hmm. So,
From
sorry,
the stem and leaf method.
Right.
From the stem and leaf method. Can I go about after that? Moving my frequency into class interval.
Sure. Yeah, you can do that. So we'll talk. Yeah. So if you wanted to do class intervals from like 30 to 39 and 40 to 49 and 50 to 59 and so on, then this will tell you exactly the frequency in those intervals. So for a stem and leaf plot, it's kind of a very specific class interval where the intervals are done by the first digits. So it's kind of a special case of class intervals.
Thank you.
Okay, you're welcome. Okay. So we only have a couple more minutes. Let me just, I want to say one more thing about stem and leaf plots before we stop. So let me share the Zoom screen again. Let me mute everyone. Participants. Okay. So one of the nice things you can do with the stem and leaf plot is that you can do a comparative plot also. So for instance, let's say we wanted to compare. So this is the same data set for Northern Africa. And now we have a different data set for Central Africa. And this is big enough that I think it probably includes Liberia. I think they're probably just breaking Africa into Northern, Central, and Southern. So I assume Liberia would be considered central in that case. So in this case, we have 2 different data sets which are measuring the same thing. It's all of them are percentage of primary school age children enrolled in school by country. So that we have the same data, but it's collected from 2 different samples. So we're actually going to have 2 data sets. And so in fact, you can, if you have 2 data sets, one of the nice things about stem and leaf plots is that you can extend the you can put both of them in the same plot, where you put the stems in the middle and you put one of the leaves goes out to the right and the other leaf goes out to the left. So let me show you how that works. I'm just going to, and this will be the last thing that we do today. We'll do the rest next time. So let me say, so what this is called is a, comparative stem and leaf plot. Okay, so yeah, so I think I'll do 5 more minutes. Okay, so comparative stem and leaf plot. So what I'm going to do here is I'm going to build the stems over here, and then this side is going to be Central Africa, and this side is going to be Northern Africa. Okay, and so the entire caption, which maybe I'll put on the bottom, is percentage of primary school age children enrolled in school by country. Okay, so what are my stems? Well, all of the stems here, it looks like they go as low as 3 and they go as high as 9, right? So 34.3 looks like the lowest and 98.9 looks like the highest. Okay, so I'm going to write my stems here as 3, 4, 5, 6, 7, 8, 9. Okay. And then what I'm going to do is just fill in the data. So for Northern Africa, for 3s, and I'm going to ignore the decimals, again, just to make it simpler. So for Northern Africa, I've just got a 4. And for Central Africa, I have a 4, an 8, another 4, and that's it. So here, what I would do is for Northern Africa, I would have a 4. And then for Central Africa here, I would have a 4, and an 8, right? So I can just have it go out to the left instead of going out to the right. Okay, so let me just quickly do this for the rest of the countries. So in the 4s for Northern Africa, I have, let me round this up. So I have a 9, and that's it. And for Central Africa, I have a 5, a 3, a 1 when I round up. So a 5, a 3, and a 1. And then for Northern Africa, I have a 9. So here I would have a 9 here for Northern Africa, and a 5, a 3, and a 1, which I'll draw in ascending order. So I'll always have the lowest values. If I want to do these in order, I'll have the lowest values near the stems and the higher values as you move away from the stem. Okay. So let's keep going. Okay, so for the 5, so for Northern Africa, I have a 5 because 54.6 rounds to 55. So that's a 5. This actually will round to 60, so I'm not going to count it. So a 5, that's it. So a 5. And for Central Africa, I have an 8, a 4, an 8, and that's it. So 5 versus 8, 4, and 8. So again, I'll have a 5 and then 2 8s and a 4. So I'll write them as 4, 8, 8. And now with the 6s for Northern Africa, I have a 0. That's the 59.6 rounds to 60. So a 0, and that looks like it. So just a 0. And then for Central Africa, I have a 4, a 2 for 62, a 3, a 2, a 1, and a 7. 4, 2, 3, 2, 1, 7. So I'm just trying to remember it. So 4, 2, 3, 2, 1, 7. So here I'm going to have a 0, and then 4, 2, 3, 2, 1, 7. So that's a 1, 2 2s, a 3, a 4, and a 7. Okay. So now we go into the 7s. So for Northern Africa, I have an 8, that's 78, and that's it. And for Central Africa, I have a 4 for 74, another 4. This will round to 80. So just a 4 and another 4. So here I'm going to have an 8, and then a 4 and a 4. Let's go to the 80s. We're almost done. So for the 80s, for Northern Africa, I have 88.5 rounds up to 89. So we have 89. So it's a 9. This rounds to 84. So a 9, a 4, another 9, and a 7. Let me just do that as one. 9, 4, 9, and 7. So that's 4, 7, 9, 9. And then for Central Africa, what do we have? We have a 5. And, well, this here rounds to 80. So a 5 and a 0. I think that's it. So that's going to be 5 and 0. And then lastly, for 9s, for Northern Africa, we have a 7, a 3, so you round up 92.5 to 3. So a 7, a 3, a 7, a 9, 99, an 8, a 6, a 2, a 5, a 7, and a 7. Okay, so that's actually more than I can memorize. So let me just try this one more time. Okay, so 7, 3, 7, 3, 7, 7379. I'm just going to write these down so I can remember. So 7379, and then 7379, and then 286259. 286259. Okay, so I'll just write these all in order. So this is going to be 2, 2, 3, 5, 6, 7, 7, 9, 9. And then for Central Africa, we have just one measurement, 98.9. So that's a 99. So that'll be a 9. Okay. So yeah, so you often round off to the nearest whole number to get the leaf. That's just going to be useful for the phrasing. Yeah, so Armstrong, so that's a reasonable principle. Again, it's not a rule. It's just usually throwing in the decimal points is just going to clutter the plot, and it's not going to give you very much useful information. So it's cleaner to just round off to the nearest whole number. So you can kind of see what's going on here, right? In Northern Africa, if you tried to like draw a curve here, it would be saying that, you know, most of the countries have 80 or 90% of the children in school. In Central Africa, you know, your curve looks kind of a little bit different, right? The bulge is around here, around 50%, 60%. And so what's nice about this is you can compare two different things on the same plot. And this took a little bit long because there was a certain amount of data, but it was still a reasonable thing to do. Okay, so I think frequency distributions and histograms were out of time, so we'll save that for next time. Are there any questions on this comparative stem and leaf plot over here?
Yeah.
Yeah, Tomas?
Can we compare more than two data?
That's hard to do visually. To do that, you'd really need to just do different stem and leaf plots side by side. To do it all in one picture, the most you can do is 2. If you wanted to compare 3 different data sets, you just have to draw a stem and leaf plot for each one and just put them all right next to each other and see what those look like. Sometimes it's nice if you have only 2 to just do it all with using the stem only once and having the leaves for the 2 different data sets be separate. But once you have 3, then you're going to have to repeat the stems.
Okay, thank you.
Other questions?
Hello.
Yes, is it?
Hello.
Sorry, who's Gabriel?
Yeah.
Yeah.
Hello.
Hello, yeah, Gabriel.
Getting me?
Yeah, I'm getting you.
Yeah, I want to know if we are working with whole numbers.
Usually we are.
With our names.
Yeah, so usually with stem and leaf plots, you're going to be working with whole numbers.
Yeah, but the whole number we are working on, if we work with whole number, how do we work with 3 teachers no more?
Sorry, I'm not getting you so clear.
I said, if we are working with whole numbers,
yeah,
how do we work with 3 digits no more?
With 3 digits, okay. So, I mean, if you wanted to, let me just make up a data set. So if we just had a data set like, you know, 123, 125, 246, 257, and 300, then what you could do is you could do this. For your stem and your leaf plot, I could have 1, 2, 3, and then I could list like 23 and 25 over here for the 1s, 46 and 57 for the 2s, and 00 for the 3s. Or you could just decide that you're going to ignore the last digit. And you could just say 1 and then 2. You could just say 2, 2, and, you know, 4, 5, or round if you want to, and 0. And in that case, you would just have to label your diagram as 10s so that whoever's looking at it knows that you don't actually mean 12, you mean 12 10s. So you mean 120. So you have your choice, whichever one you want to do. And again, there's no rules. It's all just about what is going to give the most useful information to the audience, right? The only rule is the place value has to be consistent in all of your data. Everything else is about interpretation and taste. Okay, so let me just say very quickly, so we're going to skip all the histogram stuff. You're welcome. But so there are a couple of homework exercises that when I post this, they'll be there. So one is just suppose we have a survey where people are asked about the highest level of education they've completed, primary school, secondary school, university, or graduate school. what do you think would be the most appropriate way to visually present the resulting data? And then the challenge is also to go make a stem and leaf plot for the following data. And so this is just the population of every county in Liberia in 2008. And I'm not going to give you any further guidance. The question is, I want you to choose the stems and to choose the leaves in a way that makes the picture the most useful. So people will have maybe different ideas of how many digits to put in the stem and how many digits to put in the leaves. So think about, what you think is going to be the best. So again, I will post this. I'm going to send it to the chat. I'm going to post it on the website, so you'll be able to see everything. And next week, we'll talk about frequency tables, classes, and histograms. And we'll also talk about cumulative frequency plots. Okay, so thank you very much.
Thank you.
And I see Sange is here. So welcome, Sange. It's good to be in a room with you.
Thank you, Andrew. It's good to be back.
Good. Are you back in Liberia?
No, I'm here. I just got a number, that's why I'll try to call you later.
Okay, great. So I'm going to stop the recording now.